chapter Climate. In previous class, we have learned weather and climate, differences between weather and climate, regional climatic variation in India, climatic controls. Today, we will learn about the factors affecting India's climate, jet stream, and how does jet stream influence upon India's climate. So let's start with the first topic for today's class, and that is factors affecting India's climate. Students, we have already studied that factors that affect the climate on earth in previous section. In today's topic, we will learn about which of those factors plays a vital role in deciding India's climate. Among these factors, latitude, altitude, and pressure and winds influence India's climate the most. So let's start with the first factor that affecting India's climate, and that is latitude. We know that the Tropic of Cancer, which separates the tropical areas and subtropical areas of the earth, passes through the middle of Run of Kutch in the west to Mizoram in the east. Therefore, the climate of India has characteristics of both tropical and subtropical climates. This line is very important. Remember, India's climate has characteristics of tropical as well as subtropical climates. Justify the sentence or explain the sentence. Like this question you will face. So remember this. India has very tall mountains of about 6,000 meters. The Himalayas prevent the cold winds from the Central Asia from entering India. Okay. So Himalayas just act like a barrier. It is due to this reason that India has a mild winter as compared to Central Asia. The biggest influence on India's climate is pressure and wind condition. During winter, the northern area near the Himalayas has high pressure. Therefore, winds from this region blow to the south where the pressure is lower. In summer, the northern part has lower pressure. Therefore, there is a reversal of wind direction. The winds from the south blow towards the north. These winds greatly affect the climate of India. Now, my dear children, we are going to discuss about the relation between pressure belts and planetary winds. You know that the Earth's surface, there are 7 pressure belts. They are equatorial low, the 2 subtropical highs, the 2 subpolar lows, and the 2 polar highs. Look at the diagram. Equatorial low region, the subtropical high pressure area, subpolar low pressure area, and polar high pressure area. So you know that except for the equatorial low pressure area, the others form matching pairs in northern and southern hemisphere. There is a pattern of alternate high and low pressure belts over the earth. This is due to the spherical shape of the earth. The different parts of the earth are heated unequally, isn't it? So all the equator, the ground is intensely heated by the sun. This is cause the air to rise, which creates a low pressure zone in the equatorial region. Okay, got it? Already we have discussed about the pressure zones. Now we are going to discuss about the winds that present over the in between the pressure zones. So first of all, the polar high, in between polar high and subpolar low in the northern hemisphere is polar easterlies. In between subpolar low pressure area and subtropical high pressure area in the northern hemisphere is westerlies. Polar easterlies in between the polar high and subpolar low pressure area. In between subpolar low pressure area and subtropical high pressure area is westerlies. And subtropical high pressure area in between equatorial low pressure area is northeast trades. In between subtropical low pressure area in the southern side subtropical high pressure area is southeast trades. Okay, got it? Next one, subtropical high pressure area and subpolar low pressure area, the wind present over there, westerlies in the southern side. And the wind present over in between the subpolar low area and polar high area is polar easterlies. You know that winds always blow towards the low pressure area, isn't it? So just like from subtropical high pressure area towards equatorial low pressure area. from the subtropical high pressure area towards the subpolar low pressure area. It is a normal pattern, but sometimes winds get deflected towards right side in the northern hemisphere and left side in the southern hemisphere. Now, my dear children, we are going to find out what cause wind to get deflected, isn't it? So an apparent force that arises because of the earth's spin around its axis is called as Coriolis force. The Coriolis force is responsible for deflecting wind towards the right in the northern hemisphere and towards the left in the southern hemisphere. This is also known as Ferrel's law. Ferrel's law says that when the winds pass the equator from southern hemisphere and enter the northern hemisphere, they suddenly turn their direction towards right, and it happens due to Coriolis force. Got it now? So, Coriolis force affect any object moving horizontally on Earth's surface, such that they turn towards right in northern hemisphere and towards left in the southern hemisphere. This mostly happens with the rivers, is it? So the Ferrel's law, we can say that Ferrel's law is just an application of Coriolis force. We know that Earth rotates or spin on its axis once in every 24 hours, isn't it? Since the Earth is a sphere, the speed of latitudes are different from one another. Different parts of Earth moves at different speeds. As the latitudes increases, the speed of the rotation decreases, just like in temperature. Okay. So remember, at the equator, the speed of the Earth spin about 1000 miles per hour. Assume yourself in the subtropical high pressure area. ओके सो आप सोचो कि आप सब ट्रॉपिकल हाई प्रेशर एरिया पे हो और वहां से आपको एक बॉल फेंकना है इक्वेटोरियल लो प्रेशर एरिया पे. सो ऑल्सो यू नो दैट द स्पीड ऑफ द अर्थ स्पिन ऑलमोस्ट अबाउट 1000 माइल्स पर आवर. तो क्या होगा, जो एक्चुअल पाथ है वहां से वो डिफ्लेक्टेड होके राइट साइड पे गिरेगा और वी कैन से द बैक साइड पे गिरेगा एंड इट इज ओनली फॉर the earth rotation, or we can say the only due to the Coriolis force. Got it? So northern hemisphere the winds always get deflected towards the right side and the southern hemisphere always get deflected towards the left sides due to the earth rotation, or we can say due to the Coriolis effect. Let's move to the next topic for today's class, and that is jet streams and how does jet stream influence upon India's climate. Jet streams are currents of air high above the earth. They move eastward at altitudes of about 8 to 15 km. They form where large temperature differences exist in the atmosphere. Jet streams are some of the strongest winds in the atmosphere. Their speed usually range from about 110 km per hour in summer to 184 km per hour in winter, but they can reach more than 443 km per hour. They are faster in winter when the temperature differences between tropical, temperate and polar air currents are greater. A number of jet streams exist, but the most constant are mid-latitude and subtropical jet streams. The jet streams located over 27 degree to 30 degree north latitude and known as subtropical westerly jet stream. I am going to repeat. The jet streams located over 27 degree to 30 degree north latitude are known as subtropical westerly jet stream. These jet streams blow south of Himalayas throughout the year except in summer. These are responsible for western cyclonic disturbances experienced in the north and the northwestern part of the country. This jet stream move north of Himalayas with the apparent migration of the sun. During the summer at about 14 degree north, an easterly jet stream called the subtropical easterly jet streams blows over peninsular India. The winds that batter the top of Mount Everest, Nepal are jet streams. Jet streams are cold, fast-moving winds that circulate high in the atmosphere. Jet streams pose a major danger to climbers on Mount Everest. With freezing winds at 120 kilometers per hour, climbers are struck until the jet streams lie down. So, my dear children, that's enough for today's class. We will meet in our next class with new topic. So, till now, bye. Take care and have a